In this lesson, we're going to work a couple practice problems, getting familiar with the equation. Of course, velocity equals displacement over time. And we can rewrite that, remember, in two other ways. We can say delta x, or displacement, equals velocity times time. Or we can write that as time is equal to change in position, displacement, divided by velocity. So whenever we work a problem, we're always going to work them in the same way. We're going to list the information that we're given in the problem. We're going to look for what we're trying to figure out, and then we're going to pick the right tool, and by tool I mean equation, in order to solve for what we want. And you're going to show me all of those steps. So when I ask you to show work, this is what I'm asking you to do. So the problem says determine how long it takes a car driving 25 meters per second to go 250 meters. Look for the units because they tell you things. 25 meters per second. Meters per second is the unit for velocity. So I can go ahead and say velocity equals 25 meters per second. That's the first step in showing work. I've got my list of information. Determine how long it takes a car driving 25 meters per second to go 250 meters. That's our displacement. How far did it go? 250 meters. And it says how long, that's how much time. So I'm looking for time. Time is my unknown. Those are my three things that I'm given in the problem. Two of them I know, one of them I don't, and I want to solve for time. So I come over to my tools, and I see that the equation that allows me to solve for time is this bottom one. So time equals displacement divided by velocity. I'm going to write that down because that is the tool I'm using. So change in position divided by velocity. And now I'm going to show where I sub those numbers in. So since displacement is 250 meters, this becomes 250, and velocity is 25, that goes right there, so divided by 25. And this is meters, and this is meters per second, and so when we do this, we're actually going to end up with just seconds. This fraction inverts and multiplies, so I have 250 divided by 25, and 250 divided by 25 is 10 seconds. And so I do get how much time it takes. It takes 10 seconds to go 250 meters at 25 meters per second. Now over here we have a different problem. This problem says how far will a person go in 40 seconds if they are running at 7 meters per second? Again, we're going to look for what we know and what we don't know, and we're going to list it. So what do I know? I know 40 seconds. Seconds refers to a time, so I'm given a time, 40 seconds. If they're running at 7 meters per second is a velocity, so V equals 7 meters per second. And we're supposed to find how far, that's a displacement, so delta x is my unknown. And so I come back to my list of equations and I see this middle one, delta x equals velocity times change in time. I'm going to write it down, delta x equals velocity times time, and so I can plug in the things I know. Velocity goes in first, and time goes in second, so I get this is delta x equals v, 7, times t, 40, and this is 280 meters. And your unit there works out because I have meters per second times seconds, and so that second cancels that second, and I'm left with meters. So 280 meters is how far I'll go in 7 seconds or in 40 seconds at 7 meters per second. Always show your work.